Hello friends, welcome to Daring Marana YouTube channel. Today we will be discussing about some question set number 4. Okay, so this will be discussing about questions mainly for the motor MEP and all. So causes of cylinder head cracking. Okay, so mainly due to scale deposits or inefficient cooling water or uneven tightening of bolt and fuel valve, fluctuating cooling water temperature, that means excessive temperature gradient, overloading or raising of engine, then fault relief valve, mechanical failure due to gas corrosion or acidic corrosion due to leaky exhaust valve and or water side corrosion. Okay, these are the reasons for the causes of cylinder head cracking. Causes for the cylinder head cracking are scale deposit, inefficient cooling water, uneven tightening of bolt and fuel valve, fluctuating cooling water temperature, that means excessive temperature gradient, overloading or raising of engine, faulty fuel valve, mechanical failure due to gas corrosion and acidic corrosion due to leaky exhaust valve and water side corrosion. So what is normal relief valve setting of cylinder head in a DC engine? Normal relief valve setting of cylinder head in DC engine is 10 to 14.5% more than the working pressure, about 120 bar or somewhat higher than maximum pressure. So normal relief valve setting of cylinder head in DC engine is between 10 to 14.5% more than the working pressure, about 120 bar, that is somewhat higher than maximum pressure. Then you know that in a ship we use uniflow scavenging. It is most in two-stroke engine. We follow uniflow scavenging. So what are the advantage of uniflow scavenging? Simple liner construction is that longer skirt for piston is not required. Stroke length can be increased. High scavenging efficiency and high thermal efficiency. Low grade of fuel can be burnt. Uniform wear of piston ring and liner. Less thermal stress. Less intermixing of scavenging air within exhaust gas. Exhaust valve can be made to open late. More work. Close early. Scavenger is more utilized. Okay, what are the advantage of uniflow scavenging is simple liner construction. Long skirt for piston is not required. Stroke length can be increased. High scavenge efficiency. High thermal efficiency. Low grade of fuel can be burnt. Uniform wear of piston ring and liner. Less thermal stress, less intermixing of scavenge air with exhaust gas. Exhaust valve can be made to open or late, then more work or we can close early, so that scavenge air is more utilized. Okay, these are the advantage of uniflow scavenging. That means simple liner construction, long skirt or piston is not required, then stroke length can be increased, high scavenging efficiency, high thermal efficiency, low grade of fuel can be burnt, uniform wear of piston ring and liner, less thermal stress, less intermixing of scavenger with exhaust gas. Exhaust valve can be made to open late, that means more work, that is close early, so that more scavenge air is utilized. Then why cylinder liner wear is more at the top? Why we can see cylinder liner wear more at the top side? Because high temperature exposure due to combustion gas. We know that due to there will be high explosion of the gas will be there, so that high temperature exposure due to combustion gas, loss of liner lubrication in low speed diesel engine, then corrosion, predominantly acidic corrosion due to combustion products, then fuel impingement deposit, change of direction of piston which causes step leg formation of reversal point. Why cylinder liner wear is more at the top means high temperature exposure due to combustion gas, loss of liner lubrication in low speed diesel, then corrosion predominantly, that is acidic due to combustion products, then fuel impingement deposits, change of direction of the piston which cause step leg formation of reversal point. So what action do you take in case of stern tube of ship start leaking? What will be the action when the stern tube of the ship start leaking? Means we will maintain low head, use higher viscous oil, replenish periodically to counter for the oil loss, drain off the water periodically, try to remove foreign particles by changing the direction of shaft. So if there is a stern tube of the ship start leaking, so what are the actions that we need to take is we need to maintain low head, use high pressure, so use high viscous oil, replenish periodically to counter the oil loss, drain off the water periodically and try to remove foreign particles by changing the direction of shaft. And how do you test a freshwater generator plant for leak? So how do you test freshwater generator for this leak? We have to close the outlet of the distillate pump, vacuum breaker valve, bottom blow off valve and feed water valve. So we have to close the outlet of distillate pump, vacuum breaker valve, bottom blow off valve, feed water valve, and we have to inject air into evaporator shell. Inject air into evaporator shell, keep the shell pressed up to about 1 bar gauge. So we have to keep the shell pressure up to about 1 bar and sprinkle soap solution onto jointing, packing and suspended area of shell. We have to sprinkle soap solution to the jointing, packing and suspended area of shell. So how do you test freshwater generator of a plant for its leak? Means close the outlet of the distillate pump, vacuum breaker valve, bottom blow off valve and feed water valve. We can inject air into evaporator shell, keep the shell pressure that is pressed up to about 1 bar gauge, then sprinkle soap solution on the jointings, packing and suspended area as well. If there is leakage, there will be soap bubbles will be formed. Okay. Then what are the reasons for piston crown to crack? A reason for a piston crown to crack is casting defect, thermal stress due to cold starting air and scavenging air, scavenge fire, overheated piston, that is cooling failure, cooling state deposit due to oxidation of the cooling oil after burning, faulty fuel injection system, that is more penetration or loss of atomization. Reason for piston crown to crack means casting defect, thermal stress due to cold starting air and scavenge air or scavenge fire, overheated piston. Overheated piston means cooling failure, cooling state deposit due to oxidation of the cooling oil after burning, faulty fuel injection system, more penetration or loss of atomization. What are the reason for black smoke from the diesel engine? From what are sometimes we can there will be in some situation there will be black smoke coming from the diesel engine. So what were the reason? That means poor combustion due to faulty injection system, low compression, insufficient scavenge air, fouled exhaust system, broken piston ring, ineffective lube oil seal after burning or bad fuel and other fuel assisted fault, faulty cylinder lubrication. During starting, it is inevitable as an engine maker sets starting fuel index to a fixed value. At this index, there is insufficient air, so low piston speed, cold combustion chamber, low fuel injection pressure, etc. So each compounding to the cause of a black smoke. So what are the reasons for black smoke are poor combustion due to faulty engine system, low compression, insufficient scavenge air, fouled exhaust system, broken piston ring, ineffective lube oil seal after burning, bad fuel and other fuel assisted fault, then faulty cylinder lubrication. During starting, it is inevitable as an engine maker sets the starting fuel index to a fixed value. At this index, there is insufficient air, low piston speed, cold combustion chamber, low fuel injection pressure, etc. Each component to cause for a black smoke. So what are the critical speed effect? Critical speed effect, they mainly due to resonance, torsional vibration, fatigue failure of the components can be remedied by detuners, vibration damper, electric vibration compensator unit. Okay. Critical speed effect means resonance, torsional vibration, fatigue failure. This can be remedied or we can reduce due to detuners, vibration damper, electric vibration compensator unit. Okay. What are the types of vibration in diesel engine and which is the most damaging vibration? Okay. Types of vibration are linear vibration and torsional vibration, resonant vibration. Involving any of the two above may be in or combination. Okay. Most damaging form of vibration is the torsional vibration mode affecting crankshaft and propeller shafting. Okay. We know the types of vibration means linear vibration will be there, torsional vibration will be there, resonance vibration. That means that involve either linear vibration or torsional vibration. Okay, combination. And most damaging form of vibration is torsional vibration affecting the crankshaft and propeller shafting. Okay. So these are the question set number 4. We will be coming and discussing more about the questions of motor MEP. Thank you.